yesterday, and everyone is here waiting. So that's great. So thank you everyone for attending. How many people here are from MSI? Is everyone? How many people aren't from MSI? That's fantastic. Thank you very much for coming. Product teams. Should I have a measure how many people are from the CLR team? Thanks for coming. Working with product teams is fraught with difficulties sometimes, and one of those difficulties is that product teams have to ship products and get every bug out of the product, or almost every bug. And the CLR team, the developers in particular, have been told this week, unfortunately, that they must work on bugs and not attend any meetings of any kind, either their own or this meeting, unfortunately. So the developers haven't been able to make it over, but we do have some of the architects here, and so thanks for coming over. That's it. I think we can just move on. You've all seen the program, so you will know what the contents of what today is about. It's just looking at a range of issues to do with the common language runtime or with .NET, and there's really just an open invitation to talk about ideas about software, the software platform, or where the platform will go over the next few years. So it's really just to try out whether we could get together some people from both product teams and Microsoft Research, and to share some ideas just in a fairly relaxed day, I hope. Feel free to stop and ask questions and generate some discussion. And I'm sure we'll follow up with similar workshops like this. So if you've got ideas that during the day that come to you, then in 6 months or a year's time, then think about giving a talk at a similar sort of MSR, MS combined event. That would just be wonderful. So, but let's just move on with our first talk on Rotor.
Morning, ladies and gentlemen. Can everybody hear me okay? Good. My name's Steve Walli. I'm a program manager on the Rotor project. I'm fairly new to the team, and so I'm still coming up to speed myself on some of this, but I've brought along Barry Bond, who's been one of the developers on this team for quite some time. So if you want to drill down on some technical questions at the end, there'll be no problem. We've made sure we've got you covered. Rotor's kind of an interesting project, and I'm going to talk about what the project's goals have been, go over the licensing that we're going to bring Rotor out under, because it's very unique from a Microsoft product perspective. We'll talk a bit about the ECMA standards organization and what Rotor has to do with all of that. We'll go over the architecture at a very high level, and then I'm going to drill down in a couple of places, one being the platform adaptation layer, which is how we're bringing Rotor onto other architectures, and the other will be in the base class library selection criteria that we used. So what is Rotor? Rotor, for all intents and purposes, is a reference implementation of the C# language specification and the Common Language Infrastructure specification for ECMA. There will be key software development kit tools that ship with that, and it's being provided in source code form. This is not a traditional Microsoft product at all. The source code will actually be available under very liberal licensing terms, and we'll talk a bit about those. And the intent of this is that it will run not just on Windows. This will also run on FreeBSD out of the box. So why are we doing such a strange, not quite a product, and releasing it in source form? Because this is Microsoft. The primary thing we're doing is to support the standard. The ECMA standard is very important to us as a business as we take .NET forward in the .NET framework, because we want large corporations to have that confidence that this isn't just a Windows thing. That's not the way they buy products. So number one thing is to prove that .NET is not just a Windows thing. The other thing we want to do is to start to bootstrap our community again. We've taken a lot of heat over the last couple of years in the Linux threat, the fact that Linux is showing up in all the research facilities. Linux is very interesting to academics and teaching as a teaching platform because you can get at the source code. So again, by making Rotor available in source code form, we hope to begin to drive a community effort again and get some interest around people exploring and experimenting with the Rotor source base. Basically, the ECMA standard is the common useful subset where our .NET world, the .NET framework, and things like Starlight come together. And so again, Rotor is one more take on that, again, to try and drive this idea of exploration, experimentation. And it really is something that we want to bring to other platforms. Now, we're Microsoft. We're obviously not going to turn around and ship a product on Unix today. Certainly not on Linux today. But that doesn't mean we shouldn't be proving or encouraging other people so to do. And, sorry, the acronym in the final bullet there is write once, run anywhere. I take it half the room is probably completely familiar with it, and the other half may not be. So how do we do this? How do we do this under a license that, again, is not a typical Microsoft license? This is all part of the shared source initiatives that were kicked off in the spring time frame by Craig Mundy. Essentially, we've stepped back and we've said that, okay, there's a software ecosystem, and we believe in the commercial end of that, and that's based on, you know, a strong community of developers out there, and standards, and protecting your intellectual property and running a profitable business. But we also want to get back into the idea that we are a community of developers willing to share. There are things we can learn from the open source community without necessarily becoming an open source company. So we've come up with this idea that there's a shared source program, and that'll encompass, it's the umbrella program for many different licenses. The Windows CE license is one of those licenses. The source access, that's the CodeShare project, where we're allowing a lot of our large customers access through a web front end to the NT source base is another part of that. So basically, we will come up with a single license that will cover C#, the CLI, and ECMAScript, because ECMAScript will also be ported into this space. And the nature of these liberal licensing terms are it will be freely available and freely distributable for non-commercial purposes. So anybody can go and experiment and explore or play, toy with it, do whatever they choose to do with it, and distribute their work as long as it's not going into a commercial product. For that, you have to come back and talk to us. We run profitable businesses here. The other thing, though, that's one of the driving factors, though, is we do want to encourage people to get out there and build real implementations on other platforms. We want to drive the web services idea. We want to drive it through our technology as much as possible. And ultimately, we want to have the best implementation. That's what the company's all about. But in so doing, we want to allow other implementers that will be building commercial products to turn around and kind of open the box and see how we did certain things without fear of being tainted. How many people have seen the WinCE license? Okay, a couple, good. That's basically where we're going. We are still soliciting feedback. So if you've got other ideas that from a research-oriented point of view you want to ensure that certain things are looked after, we would absolutely encourage you to give us your feedback. So the ECMA submission, ECMA is it's primarily a European standards organization. It used to stand for the European Computer Manufacturers Association. It's the same type of organization that built the C language standards in North America originally. There are two pieces to this standard. The first one, the list of the 5 partitions there, that's the CLI. And it's big and unwieldy. I don't know how many of you have participated in standards efforts before. This thing does measure in the 1,000-page kind of range. And then the last spec is the C# programming language specification. The base class libraries in the CLI spec is actually kind of an interesting thing because we're shipping it in 2 different formats. One, the standard itself will actually be XML. And so we're going to provide all of these Word doc things as kind of a helper to the reader, since most people don't just read XML lightly. But these are the kinds of things that have gone into the core base class library. It's all the kinds of things that you would expect to see this is the common subset that we've cut down, and I'll talk about the cut down criteria in a few minutes. Now, one of the interesting things that comes out of all of this, though, is, remember, this is something that Starlight wants to implement as well. So you end up in this space that you need to profile this work. So there is a core piece of this defined as the kernel profile. And that is something that will actually be incorporated into the C# language spec. Because again, C# as a language spec is interesting, but it's not particularly useful when you can't actually do anything with side effects like I/O. So you have to end up in this space of, okay, so there's a core to the library, and then you add that next circle of functionality, which is the stuff that the people in Starlight care about. So that's the compact profile. And then there's still some additional libraries that you really do want along for the ride, and that's what comes into the rest of the package. Rotor as an architecture, I don't have a strong feel yet for the audience I'm speaking to. I'm sorry. So I don't know how many of you could kind of draw this slide by yourselves at this point. But the things that are interesting about Rotor, because we're bringing this to other platforms, you've got the PAL layer down at the bottom. We've basically taken a traditional approach of how do you get Windows-like things up on Unix. We had to evaluate different JITs to come up with the best JIT for this project. Remember, one of the goals of the project is to allow people to go and explore and experiment, but one of the other goals is not to release all of our IP into the community. So we've chosen a different JIT. We've chosen a simpler garbage collector. Again, same kind of criteria there, that we are trying to encourage experimentation without giving away the keys to all the kingdom. And one of the other things that was kind of a bit of a challenge that I'll talk about is how do you do anything that's graphic? How do you build a GUI that's platform independent? Now, there's lots of ways that have been approached kind of in the industry over time and in some of the research communities, but it's still something that, again, we had to make a choice in that space, and I'll talk a bit about that. So let's talk about the PAL. Essentially, this is a traditional way. How do you make sure that something will run on both Windows, looking at an NT kind of kernel interface, and a Unix world? Well, the way we're building Rotor, we are not starting from the standard and building up. We've turned around and we've started with .NET on Windows, and we're cutting down. And so this is very much Windows-centric, Win32-centric code, top to bottom. And so by the time we've come through the cut down, the evaluation that's been made allowed us to actually make the choice of we need this subset of the Win32 API. We're trying to make minimal changes to the .NET on Windows code base, but some changes have been populated back into it. And essentially, it's coming up with that mirror layer, that shim of code that looks like Win32 and runs like Unix underneath. The PAL is being used across several pieces, not just the common language runtime and the frameworks, but also all the unmanaged tools. So any of the tools in the harness that are not written in C# have to use the PAL layer as well. At this point, there's, just as a spec number, there's about 200 interfaces that we really couldn't, cut past it. You couldn't do any simpler.
How big are those interfaces?
Sorry?
Sorry, how big are those interfaces? I mean, do you mean single calls, 200 calls? Or
200 calls.
100 methods, right?
Yeah.
Okay.
Excuse me while I consult my technical reference at the front of the audience.
So I thought you meant 200 sets of functions.
No, not at all. It's on the order of 200 calls. And that's it. The Win32 interface is a very rich interface. And when you start looking at things, though, what is that really core common set of things that an OS kernel does? It often falls down into that 100 to 200 kind of level. My background is a lot of Unix, and the Unix specification, the original Unix spec, was on the order of 120 calls. It was considered to be the common subset. So, I mean, you're dealing in that kind of order of magnitude. the GUI was actually kind of interesting. So how do we provide some kind of a graphic user interface to all of this? We did not want to do WinForms. First of all, we didn't want to offer up the intellectual property, and also it completely complicates the PAL. The PAL becomes considerably bigger when you're trying to do all of the Win32 GUI aspect of things. So there was a survey done basically to look at, okay, well, what can we use? Inside of Microsoft, there's a number of solutions. Problem is, none of them have kind of critical mass within Microsoft. And outside the company, there's no mind share at all. So there wasn't any particular strength in picking anything that we already were doing inside. If you step outside and start to evaluate different ways of looking at GUI interfaces, you run into this kind of, okay, well, we're not going to support Linux in the first place. And then you can even step into the whole battle. They can't even settle on an interface. And we're sure not going to pick one in that community. You start looking at other things in that world in general, you run into the whole, well, here's an interface that runs in both worlds, but you have to license it, and it's got very egregious licensing terms on Windows. And free for the rest of the world, got to spend money on Windows. Or there's things that the programming model isn't necessarily any better than the Win32 GUI programming model, things like that. What we ended up choosing was actually the TK widget set. This is something that the original work that John Osterhout had done. He brought that all over to Win32, so we knew that we could bring that up on the Windows side of the house. And then it's also got its X implementation on the Unix side of the house. So we all agree it's not the best interface, but it's free. It fits the research community element of the Rotor project, and it runs in both worlds. A lot of the choices that we've made around this are not necessarily to go for the most performant thing. Again, this is, some of the aspect of the research of this is people may go off and do garbage collector research or JIT research in this space. So we're not trying to build a high-performance, product-ready kind of source base here. So in a similar way to go in with this other GUI that may not be the best GUI in the world, at least it's a GUI that you can play the cross-platform experiments with. When we actually stepped into this, sorry?
Well, where does Tickle fit into that story? The TCL language at TK sort of...
The question is, where does Tickle fit into that? Tickle is the scripting engine that uses the TK widget set. There are just enough, there's 4 interfaces, was it? All of 4 interfaces in the Tickle space that you need to allow you to run the whole TK widget set. So we aren't porting Tickle as a scripting language into this arena, but those 4 things to actually initialize the Tickle engine and get it going so it can run the TK widget set were brought across.
A lot of the helper code that comes with the TK widget set is actually written in Tickle, like a lot of the built-in behaviors for menus and so on. A lot of it is written as this high-level Tickle code. I mean, well, you'll have to face that sort of question as you go along.
Yes. Save that question for the end, and I'll get Mr. Bond up and hook him up to the microphone. As I said before, what we basically started with was the idea that you're going to start with .NET on Windows and start cutting down. This was not brand new implementation. We wanted to ideally remove things that were strongly our IP, things that were trade secret, things that were absolutely Windows specific. Again, this is where we got into the whole debate around WinForms and whether or not it even made it to the spec and such. And we're keeping this down to the basics. So what are the implications of this? Things that didn't make the cut. There is no COM interop in this space. The Windows forms, all the WinForm stuff was gone. ASP.NET. That's one of our big drivers in the IIS world. We're not giving that up right now. Thank you. Not going into the spec. It's not going into Rotor either. Any of the Microsoft-specific database work did not make it in. And in terms of VS.NET, we are bringing across the C# compiler, obviously, and the ECMAScript compiler, but there's no part of Rotor that says we're going to bring C or C++ compilers across into this space. And Rotor won't load IJW images, things like that. So it was this idea of how do we cut it down. Rotor will be more than just the ECMA spec. The ECMA spec really is the common subset. You can do almost useful things if you had just the ECMA spec. Think of it like the original subsystem work that was done at Microsoft on NT. The POSIX subsystem was an exact implementation of the POSIX.1 standard and virtually useless because of that. You almost couldn't do anything useful. So that's how come Rotor is a little more than just the spec, because you want people to actually have a rich environment in which to do some work. The original POSIX side of things, we didn't want to give them a rich environment to do some work.
Mm-hmm. You did brilliant.
In terms of availability, current targets, Q1, Q2 of next year is when we'll bring out the beta. And a quarter or two after that, we'll follow with the full proper source release. We are thinking of ways right now, how do we go through the community building exercises around this source release? And again, that's an area that we're absolutely interested in feedback. You are a research community yourselves. You work within that community regularly. Ideas that you might have in how we drive some of this and how we encourage people into this space are absolutely welcome. Additional resources for what we're doing, there is the project website. That's the first and best place to always start on any of this. Our contacts, I believe, are in there. You can always send me email. My alias is Walli, first initial and last name. You can always look at the ECMA specs. They are settling soon, but there are drafts up right now. Then there's the standard white papers, the shared source initiative, and the actual original announcement on this that kind of lays the public boundary for discussions around Rotor is up under the shared source website. Any questions? Yes, sir.
Can you say a few words about the JIT, how it's being implemented, the handwritten?
Mr. Bond, would you come up here, please?
Sorry, can you hear me okay? Great. So we're just still finalizing our decision as to what we're going to do for a JIT. Mostly, since we're driven by a fairly short development schedule and very limited resources to do the work, we're likely going to be reusing an existing JIT rather than writing a new JIT from scratch. So our current best candidate is the fast JIT, the FJIT, that's in the desktop product right now. Has the right sort of combination of simplicity to read and reasonable portability to a different platform without giving away, our full optimizing JIT, which is extremely x86 specific.
You're keeping the security infrastructure in, like the start walking on the runtime link thing?
Yes, we're keeping all of the security features. Those are actually in the ECMA standard, so they're required for ECMA compliant implementations.
Also, do you have any concerns that by giving the same source code that we have for the desktop, you're like opening up security concerns because people can look at holes and...
Could you repeat the question over here?
He was wondering if we have any security concerns in general about actually publishing some of the security code. That's why the two of us are kind of looking at each other and shrugging. It implements a specific security model. We are not going to get into the security through obfuscation or security we're more secure through publishing a debate in this room today. I'm sure we could probably split the room nicely on that and then degenerate into a discussion about which is the best editor. It's a good question, but there's really no good answer back because there's arguments on both sides of it. Ultimately, you fall back onto Steve Lipner's take on security, which kind of mirrors a lot of the industry. And Steve Lipner, for those that don't know, works in our Windows platform team. He's gray-haired enough that he's forgotten more about computer security than most of us ever learn. And he's one that is basically a strong proponent of security through management of your system. Yeah, you really do have to pay attention. You have to apply the patches. You physically secure the system any way you can, and whether or not the source code is available or not is almost moot. Over here.
Will you be publishing the source code for all those components, including the PAL? And if yes,
Yep.
will your licensing restrict people from attempting to cross-compile it for Linux?
Not at all. We have confidence.
Do you expect that to happen then?
We're not going to prevent it. It's fairly stock standard Unix kind of code. The license certainly wouldn't prevent you from bringing it up on any system. Yes?
As to letting the bad guys have the source code, decompilers have existed for a very long time. The bad guys will have the source code on day one,
Yeah.
period, regardless of what you do.
Exactly. So, other questions? No, sir.
Can you give like a capsule history of how Rotor got started, or how having an open source reference implementation became part of the strategy?
I can't speak to the history of it. I've literally been with the project for 2 months now. I can talk to the general business approach that large corporations, the kind of people that we want to encourage to use a web service, .NET frameworks kind of world, buy things from the point of view of they're looking for an abstract platform that they have confidence will give them longevity. Because they're doing their own homegrown application work, and that's expensive. They're going off and buying off-the-shelf applications. And in picking that kind of model, they look for things that they have the confidence in that are standard. They never want to get into the single source rat hole. Now, we all know that companies the size of Digital Equipment are never going to go away. But we might want some leverage in our discussions with our own core set of vendors, things like that. So we need, from a Microsoft point of view, moving into that kind of enterprise server application space, we need to leave kind of all of the footprints that says, look, there is a standard around this technology. It can be implemented on other platforms. And by doing the standard and then providing the reference implementation and demonstrating not just a reference implementation on Windows, but on a common Unix platform that's easily accessible to a research community, we kind of start to lay that trail of telltale signs for large corporations. So that's kind of the overriding intent.
Does the license make any comments about porting? So,
Just to be clear, the license isn't set yet.
okay.
But it really is. When you say makes any statements about
So, for
porting,
example,
there's
if I want to
no
take
limitations in the license as to what platforms you can or cannot take it.
Okay, so I can port it to Linux.
You could port it to Linux. Yes, sir.
But once you do that, are there any publishing restrictions?
You will not be able to sublicense your code. So you can publish within the restrictions of the license that we're putting on this. And so it's things like you can freely publish your work or not. It's more of a Berkeley flavor of license if you want to try and put a flavor on it. But could somebody associate the GPL with their work? No, because that's a form of sublicensing. Does that kind of capture the spirit of it?
Yep, thanks.
Yeah, I'm sounding really careful with my words right now because this becomes one of those hot topics and what-if scenarios very quickly. And I'm not trying to hide anything from you. I'm just trying to say it accurately and speak to the spirit of what we're trying to do rather than...
Thanks. Yeah, I come from Berkeley, so.
Excellent. Yes, sir.
Just out of curiosity, has FreeBSD been ported to any of the RISC architectures? Or?
Yes, it has actually. It's been ported to. I don't even know what the number is now. It's more than a few architectures. There's a significant MIPS version that runs on SGI machines and a bunch of other interesting boxes. And there's ports underway to IS64, ports to AMD64. there's an alpha version available. So it is available and relatively portable.
Are those machines going to be part of your test matrix at all, or is that someone else's problem?
We're targeting x86 only for the release, just because it simplifies the world a whole lot. But we're sort of factoring the code to be as processor independent as possible, going with a simple JIT that's basically tuned for converting IL into something else fairly quickly, that's easy to port. So if someone else does come along and want to do a MIPS version, we'd like to see that happen. It'd be awesome.
Could you say something about the garbage collector? Have you decided on that yet?
Have we?
What sort of algorithm will you be using for garbage collection?
I don't know the specific algorithm that we're using, but it's a much less tuned version than what's in the commercial retail product.
Basically, you started from the same code base and trimmed some out, or you?
Started from the same developer, Patrick Desud.
Right.
So I'm not sure precisely what he did, but we have essentially a no intellectual property garbage collector with reasonable performance.
Any more questions? Hey. This is Hoi. If Hoi isn't here, let's take a 5-minute break now, and then with luck he'll be turning up, and Todd will go for 30 minutes. 5-minute break. There's that tea and coffee.
License for Rotor done. Mark, are you going to the... I'll be at most of them, except for 11 to 12. I don't want to get rid of you guys. I want to go let me talk to you guys about doing because it seems like that would make it interoperate more
Oh, you did?
Oh no, I'm a year. I can't. I'm a year. Past a year. Yeah, Richard Johnson is great. See, well, take a look. There's that. David Walli. Anyway, yeah.
Okay. It's my pleasure to introduce Hoi Vo. He's going to be talking to us about how software might be delivered in a networked world.
All right, thank you, everybody. Can you hear me okay? Thank you for Tricia this morning who reminded me at 10:30. I thought it was early, but anyway. This is truly software demand, I guess. Okay, so basically I'm here today to just talk about Rotor.net. It's a framework that we basically come up after we work on BBT for a long time, and then we look at the .NET initiative. We know that there's no way we can deliver software the way it is. We just optimizing from Microsoft and deliver it to the customer, and that's going to be it is. That's how it's going to be running on the client system. We cannot. We found out quickly that we could not deliver in that sense because the scenario, we don't know what kind of scenario you're going to be running at the client system. That's one thing. The second thing, the binary is still going to be too large for the legacy applications. So in effect, if you don't do anything to it, you have to sit there and wait for the whole thing to be downloaded to the client system before you start running. And it sounds very simple, but it comes down to all kinds of issues we kind of come up with, as you can see later on. So at first I'll do introductions, and then we show what Rotor.net currently is, the technical challenge we're running through, and then some case study. So basically, what we're trying to do is, I think this is Office 2K, isn't it? So the animation will be off a little bit, but anyway, Money Central is a 1.5 megabyte online applications, and it is 550 KB compressed format. So when the customer has to be downloaded, they have downloaded the whole 550K to the client system before it starts running. So that's why we have a framework. We take the binary, we just stream down exactly what you need to run, because some people just want to look at the quote sections instead of just go look at the whole thing or download the whole thing to be able to run all the features inside of Money Central. We found that there's only 20% of the applications you usually need, so why not just download just that much? So the .NET challenges basically right now include the memory hierarchy, as include now network latency as downlink bandwidth as well. So when you sit at the modem line, how can you do to deal with the stress we put on the modem as you have to stream down the bytes, and there's no unified solution for software delivery. And the subscription module does not handle legacy applications. For example, in the case of Word or Office, we still haven't found the right way to deliver the application to the clients in the most subtle way possible. And there's no personalization mechanism defined for downloading software either. So basically, and also optimization need profile data. And in the .NET world, you don't know what the profile data will look like. We cannot put a PM sitting there and just think, okay, this is how the software is going to be running. You write the applications for it, you write the scenario for it, and run it through BBT, And then hopefully you can get the optimized binary down on the other line. Because in the .NET world, you can be interfacing with other components you have no idea with, and how is it going to run in the system. It's very hard to predict in that sense. So this is some high-level, 10,000 feet construction of what all the framework for Loader.NET. So basically, you have a on the server side, you have a don't look at the server side at this point. So basically, this is what represents on the client system itself. So you have right now, if you look at the applications right now, all you have is this much. The service.exe is basically comprised of a service controller that allows you to go from the client all the way to the server. So let me illustrate that a little bit so you can see what happened. So when the bootstrap code starts running, it starts requesting to service controller who HTTP to the server to bring down the bits, the compressed bits down to the client. And it will expand it out internally inside of the expanded code buffers. You can look at this buffer right here as a cache of the client system. So basically now you have, in the client system, you have two blobs of data, which is the code or data, depending on what you need. And that's exactly what's going to get running on the system itself. And you don't need to download them until you need them actually on the system to run. So when one of the expanded code buffer needed another native thunk, you bring down another chunk and then put it next to the other chunk. So this is essentially what BBT is doing anyway. So because it knows ahead of time how the two blobs of code or data can be put together inside the memory together. So basically, the service.exe is the guy who arbitrates all the requests from the client side on the client system, and send all the requests to the server side to request the client bits to come down. So the technical challenge that we have with Loader.NET is how do we break up the binary? What do we put on the server side? What do we put on the client side? All the kind of issues that we have. And the most glaring things that we have to face is with debugging. We know that debugging BBT code is not that easy because we stretch the binary all over the place, and it's not that straightforward to put it back together in such a sense that it makes sense on a client system. And when you have a disconnection, when you download something and you get disconnected, what do? How do you deal with the situation where you download half part of it, you execute half part of it, you edit the document, and then suddenly the link goes down? How do you save the data files? How do you make sure that the client can exit gracefully? Security, how do we make sure that no spoofing is going on when you download something to the client? Scalability on the server side, if 10,000 customers start beating on the server right away, how does it go to stream things down correctly and not being bogged down? And so also data file and resources. We have found out that there are another class of application beyond the legacy application we usually see, like Word and Office. Excuse me. Basically, for example, game, for example, has a bunch of data files to go with it. And also people can stuff a lot of things inside the resources of a binary. And then they load the resource and they do certain things with it. For those particular things, how do we deal with it to capture the actual request and then go to the server to download the right bits for it? And then we have a thing called, excuse me, offline application mode. For offline application mode, how do you deal with the situation where you want to download everything and then go off on the airplane and start running? At that time, you don't want to say, okay, now I want this belly. My noise is going out. Actually, how do you deal with a situation where you have a spell checking that you don't need at the time when you're running on the client at home, and then you go to the airplane? How do you get that stuff to the client now that you have no more link? What are the essential part that has to be done in order to get that situation doesn't happen? How do you deal with a situation where you have no code view information? So right now, to go through BBT or Vulkan, we're required to have full code view information to be able to do code discovery correctly. What is code? What is data? So we can make sure the determination of what has to be broken up. And also debugging. I mean, we have a fun time with debugging the problem ourselves when we were writing on this framework. So we can imagine what people would stand on the other line. How does PSS have a call from a client now, and I have half of my application running down on the client system? How do they debug this thing? How to make sure the thing goes up and running? So I'm going to go through some solutions that we propose. Here it goes again. The sparsity binary concept. We came up with this thing because we know that if we can stream down the binary in such a sense that it still retains the same format as the original binary. And in this way, you don't have to worry about at any particular moment in time when things are interrupted or things get broken up or things start falling apart. You still have on your client system the same memory footprint of the out binary as much as possible. So you don't have to worry about what. Thank you, Chris. So how do you worry about the situation where things start breaking up, and then how do you find out what your stack trace look like? What is in memory at the time? And how does it relate to the whole binary that came out from the build lab in the first place? So to solve the debugging problem, we tried to stream down everything, and then when you start running, we reconstructed the binary on the client side just like it was shipped from the build lab. But not everything in the binary is there. So it has holes in it. So basically, that's why we call it a sparse binary. It has only a stub inside of it to call out our runtime to go grab the thing from the server. The downside of this approach is it locks the binary in place. So we don't have any more dynamic optimization support for this, which is how do you do BBT on the fly? How do you rearrange things on the client side to benefit the working side optimization that we usually get out of BBT? But that was sometimes it is a small thing to give up because, for example, let me illustrate how the sparse binary works. So you have a main routine which called out to another routine up here, which I highlighted in red. It's called process usage. So this is called this routine to figure out what is the usage command line is. In the sparse binary concept, that stuff got replaced by a stuff with all zeros. So basically, you have a hole in your binary which is filled with zero, and it compressed really well because at the end you don't have anything in the binary in the first place. You just have little bit of stubs, and which those stubs are also reconstructed on the fly as well. So they're not even part of the stub binary that we download to the client. So when we expand it out, those stubs get instilled in memory as we load in memory, and the runtime takes care of all of that. Then when it starts running, the stubs start taking over. So right now, in this area right now, the first, I apologize, because in XP you would see the other one disappear. Now you see the two of them meshed together. So basically, the first blob right here is going to be the call to the runtime. And then the next blob right here is actually the code, the original code that was going to be downloaded and right into that place. So at any time that you have a problem or a GP fault happen, the stack trace will do exactly as it is if you run the same binary locally. So how do you handle data block? That's another issue that we have to deal with. When the data block has multiple reference with multiple code blocks, also data blocks is too large in size. That requires special handling because they have to have special alignments to be done. There are data blocks that depend on being close to each other because if we ship them apart, some code relies on the other buffer to be right next to it to override a little bit without causing any problem. Now we stretch it apart. Something crucial might lay next to him now. So when the thing got run over, it kills crucial data. You can say that we kind of expose bugs, but that's the part that we have to do because the original binary doesn't fail in that sense. Some special PE data block that cannot be streamed, for example, the import stuff, the export stuff, you cannot just sit there and wait for the loader to say, okay, now stream down the import, the IAT for me, because it doesn't work that way. NTDLL requires specifically a certain party in the binary to be there when you start up. So you cannot take everything out of the binary in the first place. And also single reference data block detection, so that way if something is referenced only by a single code block, we can move it directly into with a code block where we stream it down. So there's no delay in waiting for the data block to come down. So let's say that we have these code block and data blocks. And these are the reference pattern. So basically, A, B, and C reference data 1, and then C reference data 2 only. For this case, we would put data 2 inside of code, part of the same funclet as code C to be downloaded at the same time. So when code inside of the block code C is being invoked, we bring the whole thing down together. The other thing is, when A or B or C got invoked, data 1 has to come down with either one of them. So if B is executed first, data 1 will be brought down with it. And then data 1, the next time the code A or C is executed, data 1 is already on the client system. There's no need to worry about that. So we build a dependency graph that was part of the stub binary that we bring down to the client. So any part of the time that the code block is executed, we traverse the dependency graph to find out what data block is going to be downloaded, needs to be streamed down with him. And then those guys will be streamed down as needed without request from the client itself. So that's how we handle the data block issues. So now that we have the thing down in the client, what do we do with it? So we have the download cache on the client system. This is to allow you to cache everything that you download onto the client system, so the next time you start, you no longer have to worry about it. It's going to come out locally, so you don't have to stream it again from the network. So right now we use BBD profile data as much as possible for the static layout of the sparse binary. And then we cache the funclet layout schemes. We have 3 ways to do it. We base on the loading order, which is we don't do anything, we just let the thing run through, and then we say, okay, who's loading first, we put it in that order. If we don't do it, we could use the BBT layout. The BBT layout allowed the client to run with better working set trimming, because it already put things in the same order the BBT would have put them anyway. Or we can use a certain pre-computed order to put this stuff. So it's up to us, basically, how to lay out the data in the cache. The download cache for every loaded net component will have its own download cache. So, for example, Word is running, it has its own download cache. MSO is running, it has its own download cache. But MSO could be used by Word and Word and Excel at the same time. But there's only one cache for MSO, so that way you don't have to fight between each process to figure out who got which download already. So that's what I meant by multiple processes share the same download cache for the same component. So what do we do next for loader.net? Now that we have all the legacy application go through with it, we have a bunch of games going through with it. Glimpsing into the future, we look at MSIL streaming support. Currently, right now, the difficulties we have is the metadata is not cannot be broken up in a way that you can stream down things efficiently. We prefer that we have metadata per class, so that you can have a class stream down to have the metadata part of it, so that way you can have better working set as you go through them. But the issue is basically if you don't do the breaking up the metadata, we have to download as a whole chunk down to the client, and that causes a lot of stress on the bandwidth itself, because usually metadata makes up about 60% of the binary. We need a CLR hook to deal with the class loading and release. So when a class gets loaded or released, we need to know about it as well to be able to get that stuff, the notification to stream down, because we have already one level interaction from going through the JIT. So we are not right there as native binaries where you can do everything possible. You can trap every possible way in the binary by hooking up the control flow graph. How do we deal with pre-JIT binary support? Do we have to worry about that? We don't know yet. How do we stream a pre-JIT binary? That means at least we have to get Vulkan to understand the pre-JIT binary in a sense. And also, in the future, we're trying to integrate Loader.net into the platform, so that way it will be seamless when things start rolling. For example, Fusion, if we work with Fusion team to get that stuff inside of it, you don't even have to worry about what's in there. It will be streamed on the fly automatically for you. Offline application support. For example, something in the case where you have to download everything, you want everything downloaded onto your laptop to pick it on the plane. You don't want any part of it left over from the server. In those cases, Rotor.net allows you to start running up and running as soon as possible, but you don't have to wait for the whole thing to come down. But at least by the time it's done, the installation, everything would be on the client. The download cache will be full at that time. Everything will be filled out. The universal download cache. This is the idea that we bounce around with the OS team, where right now we currently BBT 340 binaries out of Windows XP. And what happened if we can have only those 340 binaries exist only as stub binaries, and then we have a huge download cache that would centralize and download cache for all the binaries to work from there. So that way we can do a better way of upgrading the OS, the system DLLs. We have a better way to organize the cache in such a way you can reduce working set even further, so reducing paging, the number of disk seeks onto the cache, to be able to leverage from the profile that we have for BBT. So that's the presentation that I have. I have a small demo that I can give, but I'm not sure at this point. I thought I had half an hour to set it up, but I guess I didn't have to. But anyway, I can copy something up there to start going.
Let's take a question first.
Sure. Yes.
Yes, so it seems that by downloading things on demand, you are going to introduce latencies at unexpected places in the program. So I was wondering if it was uncovering lots of problems or bugs in existing code, or if it was always okay, or what was the practical experience with that.
Okay. The question is, how do we deal with latency issues when you start executing the code? Now that we have to download stuff on the fly, does a program have to be dealing with that situation where you have to wait for something to come down before you can start executing it? We basically have done quite a bit of analysis on the code itself. So basically, statically, we can go through the control flow graph and figure out what part of it is needed. We can package things together in the sense so that when that thing comes down, everything is needed for him to be there except for error cases. So when an error happens, we can go down the long path to download the error code path. We don't have to worry about the regular stuff. So, or you can use a profile scenario to deal with that, so you can have a much better sense of what has been executed together, so you can package them together and stream it down instead of just doing it on the fly, like basic block level. The kind of things that we can do right now is we can use profile data to dictate what gets into the native binary and not compressed. So when you download the stub binary, everything is already part of it. So in the case where you have the editing binary, at least you should have the way to open the binary and save binary at least in the binary, the stub binary, so you don't have to stream those things down. So if you have the stub binary there, at least you can edit your work and save it if something goes wrong. But at least the binary has enough functionality that will allow you to move forward and not getting stranded. Yes.
You said that you are thinking about taking system binaries into a centralized download cache, and that would help with upgrade scenarios. I don't really understand.
I don't mean that into...
Oh, okay.
You repeat the question.
Oh, I'm sorry. In the case with centralized download cache, how do we deal with the situation where system binaries are really crucial to the system? How do we stream them on the fly? I don't mean to stream those system binaries. I want to leverage from Rotor.net download cache mechanism to put them together. The download cache is going to be part of the system. It's not going to be sitting on the server.
Yeah.
It's just basically a repository of all the code basic block sitting together on the system close together. And sometimes we can remove duplicated basic block that was part of every binary that was sitting around, like everybody linked with CRT DLL, for example. And the static CRT, we can remove all of that. You did only one copy of it. That's what I meant. Yes, Gideon.
If the error code is loaded on demand and the network goes down, isn't BSS going to have lots of very mysterious phone calls? I ran it and then my machine went out to lunch.
Okay, the question is if the error code path is crucial in a sense to say what's going on. Now, if the network goes down, how do you recover from that gracefully? We do ask the people who go through Loader.net to give at least one routine that we can call, and that error routine will be part of the binary. At least it will come up and say, network disconnected. Please connect it back again with you running. So at least we can have some graceful way notification to the user when it comes down like that. Yes, Steve?
Do you have some assumptions about the range of throughput that you're dealing with? Like, what's your target bandwidth of what you expect to have between the server and the client?
We basically, what is the target bandwidth that we're targeting? So is that DSL, 56K, or is that whatever we're looking into? I think for Money Central, where things get less than 500K, a 56K modem bandwidth is pretty good. But if you have something like you had to download at least almost roughly a megabyte of code before you start running, a DSL line would be the best one. We can throttle as much as we can. It depends on the application suite itself, because we can throttle all the way down to, we can remove everything out of the binary, or we can just start putting things back into it. So it make the stub binary grow a bit more than usual. We can throttle that level as much as we can. So it depends on what target you're looking into. I think for right now, if we look into a game, I think Mark has been working with game for Xbox. Game, the code-wise, is not that much. It's all the data files is huge. So we're looking into something like 3 megabit per second bandwidth is what they're looking into. 56K is out of the question. DSL 128K is out of the question, even for those guys, because the bitmap and the rendering stuff is too much for it.
And in debugging scenarios, do you have a different set of assumptions about bandwidth? Like, in a debugging scenario, would you normally expect that the developer would be on a fast network?
The question is, in the debugging situation, do we expect the developer on the fast path, fast bandwidth to be able to debug the application? At this point, no. We don't believe that there is any difference from the way that you're debugging the application or running the application over the net. We've seen that for Word. When we bring up Word and sit there and start typing or debugging or anything, you're not streaming down the code that you needed at that time. So the bandwidth can be used to download either code that you don't need yet or do some other things, interface with the network to do other things. So the network bandwidth can be leveraged for do other things at that moment. We don't have to worry so much about the bandwidth for debugging.
Do you try to do that? Do you try to do anticipatory fetches of codes? Like if someone is doing an interactive application and they're just typing or something, will you try to fetch the whole thing aggressively?
Yes. We have a server side, which is basically does the learning mode. And everything that got executed, we can learn through the request through the server. Oh, I'm sorry. The question is basically, can we do aggressive prefetching or not on this, with Loader.net? And the answer is basically you can have the whole server side, which can tell how out of the history of usage from the application, you can tell how much is being used and stuff like that. It can package things better for the next time the user a new user come up to it. Or you can destroy the cache. You have a new version up there. You can go up there and grab the new version. As it go through and send down the bits, it can learn as well to see how many functions it can group together and send it down at one time. So you can do aggressive prefetching in that sense. So when you grab something, it may have all the things that it needs with it through the profile, through the previous history that the server knows. On the client side, you can do certain things as well, but it's not as efficient as on the server side because he has a global picture of what the application can do. Yes.
So you're saying that the server can reorganize its map of which blocks it wants to shove down to the client based on what other clients have done.
Yes.
I'm thinking for a particular client, do you speculatively load ahead blocks using spare bandwidth, like for that one particular instance of a client? So we're not talking about a server learning for the next client, but for one particular client, are you able to sort of use unused network bandwidth to load sort of drizzle ahead blocks that the client thinks it might need at some point in the future for that session?
Okay. The client is the server can learn by per application wise can it do everything possible without the profile data that it has to learn. Right now, what we do is we have several ways we can go by with it. We use static analysis to break it down to code and figure out how the functions work together. And those are the things that we use to go by to break up things to put together in order to stream it down efficiently. The other thing is basically things like when you have out-of-component activation of different COM objects and stuff like that. There's no way we can trap those things. Then that thing we just basically run as needed. But otherwise, the server can take BBT profile data out of Microsoft, which can have some certain concept of what code should be run together. We package things together in that sense.
Static for that application, though, it's not on a per usage basis. Like two different users might be using the application in two different ways.
Yes.
So user A might need like a different profile of code loaded, but his client might be able to tell based on what code he's actually executing what he might need next, which is something the server doesn't know.
Okay. So you talked about a different scenario completely from the client.
Right.
So when the client starts doing something actually different from what the server already has seen in the past.
So I'm starting to execute this block of code, so it's likely that the next block I'll need is this one. I should start drizzling that.
Okay. Right now, the runtime that we have is actually can tell what has been running in the cache, but the things that he downloaded. We're already talking about doing the optimization while the application is not running, so that we can reorder the layout in the cache itself based on what the previous time it collect data from running. We have to throttle back. We have to work with the application at the time because, first of all, we don't want the customer to know that we are snooping behind their back. The second thing is how much overhead can we give to the client when we start running in the trace mode, so that you can tell what actually was running. The third way, if we by just looking at the download cache, you can have a certain preconception of what is actually going. We can know that for BBT purposes, and by shuffling the live code together, we already have a big gain from that. So if from the cache, we can see that the way we stream in the cache is not contiguous. That's what I'm trying to show with the demo, but we can do that offline. You can see that it reads from different part of a field in different part of the cache, not sequentially. So we can reorder the cache in such a way that those things get shoved together, close together. So that way, when you read it out of the cache, it will be in the same way that if you have BBT the application on the client itself. That will be the different optimization on the client side. But in order to do that, we have to have this framework activated on the client to be able to do that. So we have to go step by step. Yes?
So I think the question that I'm hearing from the other audience members is something along like the following. You mentioned the mode of possibility of going into a sort of drizzle mode where you could get down the entire application so that you could then go offline. Now, when I drizzle in the entire application, or can I say drizzle in the parts of it that the computer thinks I'm probably going to need, even though I haven't used them yet, without necessarily getting everything or getting those things first?
Okay. So the twist of the question is basically, how do I know what to best download? Let me paraphrase to make sure that I get the right answer. How to best download the next code blocks that I don't know that I will be using yet. How is the best way to download the right bits there instead of just go out and just grab anything and just bring it down. So basically, the control flow graph of the binary can tell you a certain part of the questions. So you can see from one point A to point B, how do you see actually how the procedure A is related to procedure L, for example. So when A, B, C, D, E is actually running, and F is not requested yet, the server can make a determination of what has to push down to the client. So there is a set of things that he will say, these are the preferred funclet I would like to shove down to the customer before the other stuff. For example, when you run near the vicinity of graphing, he believed that you probably would need the printing part of it and all the visualization of it. So he can group those things together and bring it down. Now, but how do we determine what is part of visualization, what is part of graphing? That is through the BBT process. We can figure out what kind of profile information we need for each particular phase. So that way you can partition the code in different way on the server. So when you stream it down, we can go down with these clumps in the sense. But we have to be able to determine what is being used in conjunction with each other, what context they're being used to each other. And there's no way better than the profile data that can best tell us that information. Even so that we don't need that functionality yet, but when we need that, which code block would be best to be streamed down with it? So the profile data is the best way that we could go through with it. Yes?
No, my question is much simpler. It's got nothing to do with profile or BBT or anything. Once you've done all your learning,
yes.
The question is about the low-level mechanism, which is you've decided a particular layout on the server or on the client, whatever. Once you've done all that, when you've downloaded your initial binary with a certain amount of code and stubs, right? And when that starts running, after that, do other pieces come down only on demand, or are they being drizzled to you anyway? That's because if I start this application and I run and I never hit some of these unused code portions, but I've run for 20 minutes, will I automatically have my entire application there anyway, or do I have to actually force it to load?
Right. The question is basically how do the applications going to get bit streamed down to it? Is it by strictly through request, or how does the server figure out when to push down bits? And when does the binary get its full, the cache filled up? So basically we get operate in two modes. One mode is strictly on demand, which is like Money Central. You have to be application to be running online constantly in order to run. So it doesn't make sense for him to run with the network disconnected. In those situations, you only run on demand, which means you only download what you need. The other situations where you have offline application, that's when we talked about the situation where you can take the laptop and go off somewhere you need all the bits there. The installation process would not terminate until everything got downloaded. So at that moment, it's a push technology from the server. When you can establish connection with the server, it's going to push everything down to the client until it's done. And it can use some smart and download the best part that you would need next, but that is a different side of the story. But that is a completely different mode. So when we work with Fusion, we have two different modes that we're talking about, online mode and offline mode. When online mode, you don't need to, the server doesn't have to use bandwidth or anything other than that you requested. For the offline mode, if you're done with the requesting, it's going to be pushing. Or this client would say, the service guy running on the loader.net would say to the server, I'm done with all the requests so far. Have nothing to do for a while. Now give me the next thing that you would think I would need. And then the server will stream down the most probable information down.
Thank you.
A lot of effort has been spent in the last several years to decouple our user interfaces from network function calls, things that could result in a UI becoming unresponsive. And if you do all of your static analysis and profiling, you can hopefully not undo all of that work. But as a developer, will you be formalizing guidelines for how we can write applications so that they will still have a positive user experience and not introduce any unnecessary obvious delays in a UI. I mean, like simple things I would think, like if you know you're calling into a complex block of code, do it in an asynchronous way so that the UI is still responsive. It's something I wouldn't necessarily have to do on an application that I expected to be fully loaded. So do you formalize that in any way?
Okay, the question is, how do you formalize code that has strong affinities to each other, that the developer has already been put so much effort into it, and then we go through and decoupling all of that.
Well, I think it's the UI question, right? Like with Office XP, with Outlook XP, it comes up with a box and tells you the server is being slow. Would you like to cancel it? Right. So you're going to have an analogous situation here.
Yes.
Where there's going to be an unexpected network delay.
Yes.
Is there going to be a similar thing, or is it going to be like Outlook 2000, which just hangs?
Okay.
Well, that's not my real question. I mean, I presume you'll do something so that the machine doesn't just hang, while it's downloading. But more importantly, we tell developers, look, your application is going to be downloaded in little pieces, so program it this way so that that's not an obvious penalty to the user.
So basically, the question is, how do you use the loader that to not undo certain optimization or any work the developers put in?
The question is, do you have guidelines? Do you need guidelines for developers?
Yes.
Programming this.
Yes.
Right.
There's certain part of it that we can do automatically, certain part that we need guidelines for it. The guidelines we need is basically to tell us how to package things together. The other part that we can do through static analysis, at least through the through the profile data, we can do a lot of things already by putting things close to each other because we know they're being used next to each other. If the UI that you're talking about has not been activated during the profile scenario, then we'll be at a loss because now we think that it's not being used, so we don't put it closely to the related stuff. So the guidelines is basically you have to, the module that you don't need, we have to distinguish the live code And also, code has close affinity with each other in the control flow graph. In the UI situation, we can discover a lot of affinities between functions, but part of it only is live. So we can give priority to the live code. And then the code is actually part of the whole conglomeration of the stuff that the same context that we're running can still be put together in such a way that you can download those things close together.
I think you're answering the wrong question, though.
We actually found out we have to break for half an hour to allow the streaming video to reset that. So that'll put us on an hour behind schedule. So we've got to take a break for now. So thanks.
I will be available soon.